Good afternoon, everybody, and welcome to this afternoon's session of PyCon AU 2018. Our first speaker in this block is Tim, and he will be speaking to us about Python and Docker. Please make him feel welcome.
All right, hello. So yes, I will be talking about how you run Python web applications in Docker. First up, this is me. If you want to harass me on the internet, this is various places you can find me, all over Twitters and GitHub. I work for a company called Tide Tech. We do oceanographic modeling and run a bunch of Python web applications to help us do that. So a lot of this is about what we've built to achieve those goals. This talk, it is fairly dense on code or configuration and Docker examples. Don't worry about the slides too much. All of my code examples are up on GitHub. So if you want to study the code, the GitHub's, this is where the slides are. It also has some code examples, fully functional Docker Django apps. So yeah, feel free to follow along on your computer now if you want to as well. This talk is mostly about the concepts of why I've configured Docker to run in a particular way, rather than like, this is the code you must run. This is why I've structured my applications in this way, and hopefully you can build on from that to customize your application. There are examples, as I said. There is 3 examples, and I'll cover them in detail as part of the talk. And this talk does not cover how to actually build a web application. This kind of assumes that you know how to build a Django or Flask or any WSGI Python application. This is more how you then deploy it in Docker. So it assumes you know Python. Does not assume you know Docker at all. I'll go through what basically Docker is, and the basic syntaxes of Dockerfiles and Docker Compose and how you use them together. It also doesn't cover deployment. There are a large variety of deployment strategies for Docker containers, Kubernetes or AWS, or onwards and onwards and onwards. Please go see them. I'm sure someone's given a talk about this at some point here. So first up, Docker is a way of making application images that you can run your application in. They are theoretically deterministic, so you build it and it always builds the same thing. You can then use it as a kind of as an isolated execution environment, and before the security people get at me, no, it's not as isolated as a VM. There are security risks involved if you're running Docker, but it's a lot more isolated than any other shared hosting strategy that I can think of. And you can also compose containers together and link them together to achieve multiple services in the one deployment environment that don't interact with each other unless you give them permission to, that are easy to join together, including in development, which is really handy. The basic way of making a Docker file or Docker container is through a Dockerfile. The basic syntax of a Dockerfile is up on screen. You have the first line is you say what kind of base image you're building from. In this case, I would say please start from Debian. There is a vast array of choices there. You can even just start from a Python image if you want to run a particular version of Python. You can then run any commands inside there, such as installing Python, copying in a requirements file, installing all your requirements through pip, and then copying in your application files. Another very useful thing in Docker is a Docker Compose. This is mostly for development, though you can use it in production, but it specifies how the pieces of your application can be joined together. And so in this example, I am saying, please set up this Python environment, then connect a database to that, and also run a dummy mail server. And then with one command, you can start all 3 of these services in development with no extra bother on your host computer. Really great for repeatable development environments. So I will now cover how you should structure, in my opinion, your Python application to make it really easy to deploy in Docker. You don't have to follow this, but it will, like I have my reasons for this that I'll go through, so it'll make putting a Python application into Docker a lot easier. This example does cover a Django application, but the concepts are applicable to any WSGI app. I've successfully built Flask applications in this way as well, so the Django bit of this example is fairly arbitrary. It's just something that many people are familiar with. So the application is built pretty much as normal. There are some small constraints that I'll go over, but that's most of the constraints are good development practice anyway, so that will probably be useful to you if you follow them. It runs as a WSGI application, so you will install WSGI or Unicorn or something in the container to run your application, and then connect to that from Nginx, for example, or Apache, or any other front-end server. As I just said. So this is the file structure I propose for your application. It has a README, because of course you should tell people how to run your thing. I recommend putting all of your Python code into one top-level directory, which is different to how Django recommends you do it, where you have like different directories per app. Feel free to put submodules within your top-level module, but just having one top-level module will make things easier for you later when you're copying files in. So if you want to have submodules for your blog or your contacts or that kind of stuff, just whack them in there. Or Flask, Django, all those things support this. So put everything in there, your WSGI files, your settings files, and anything else you want. Please have tests. I'll go over how to run tests in your Docker container later. If you don't have tests, there's talks on that as well. I recommend you have tests. Again, everything else you want. Requirements text. So this is for building an application at the end of the day. So it doesn't have a setup.py file for building libraries. Libraries and Docker, they're not really a thing. So that's a completely different build story. I like to have a separate directory per deployment environment. So you'll have a develop directory and a production directory. You could have a stage directory as well if you want, and that just keeps all of the files specific to that environment in one location. Easy to tell what's what in that case. So develop has a settings file, deploy has a settings file. If you needed any like extra configuration, whack it in there as well. This also has some scripts, which I'll show in detail later, that will run your application in the Docker container. And finally, you have your Dockerfile and Docker Compose sitting in the repo, and that's what we'll use to build your image and run it in development. So yeah, as I was saying, one configuration file in the main project directory, and that should contain all of the base settings that your application needs to run. It shouldn't have any environment-specific settings. That's where the other files come in. So you'll have a development in configuration, staging configuration, production configuration, and they can get their settings from wherever you need to. And then select that with environment variables or with Docker volume mount magic. Your development configuration, because you completely control the development environment in Docker, you can just hardcode all of it. It's brilliant. So everything's in the Docker Compose, so everything knows where it's going to be, and you can just put it there. You don't need magic secret keys because it's in development. You know where the database is going to be because it's running through Docker. And you can run a fully fledged SMTP receiver in Docker, which then makes debugging your emails really easy. Check that one out. I've gone now. Anyway, sorry, Docker Compose later. Check out that mail backend. It's brilliant. And then for your production image, I recommend pulling everything from environment variables. This is fairly standard in configuration, and then you can inject those using whatever system you use to run it. So Kubernetes or AWS or just plain old Docker. You can put those environment variables in, and it'll configure your thing. And the great thing about doing it this way is that you can see where all of the environment variables are in this one configuration file, and you know what you need to configure to make it work in production. So that was all Python. This is how I would build a Docker container that runs this application that I've just described. So start it from wherever you want. If you start it from the Python repos, then you can build it from whatever version of Python you want. So it's really easy to keep up to date with the latest Python, assuming all your dependencies run in it. But 3.7 was released 2 months ago, and you can already run it in production if you want. No bothering with upgrading your production images and all that stuff, or your production servers, because Docker, you can just rebuild it. Say where you're going to put your stuff. Install any dependencies you might need, for example, installing the Postgres libraries, the client library, so you can connect to your Postgres database. Copy in your Python requirements file and install it. And then copy in your files. So this is part of the reason that I recommend putting all of your Python files into one module, is just because you have to name each directory individually to copy them in. So if you just have one, it simplifies your life. Copy in your deployment, your production deployment environment settings, and then any other files like your Django manage.py as appropriate. A couple of useful environment variables for Docker. Python unbuffered means that reading input is not buffered and writing things out is not buffered. It works. I don't know really what it does. UTF-8, hardcode that so that everything runs. Please use UTF-8. I think there's a talk on that later. Use UTF-8. And don't write bytecode. So Python, when it runs something, will compile it to bytecode. That's only useful if you restart Python for increased startup times, but because you're only ever using, like, you'll start the image up and then when it closes, like that you just start a new image up. So it's never, there's no point in writing bytecode out because you'll never have a chance to reuse that in your Python image. It also kind of pollutes your development environment a little bit and can lead to strange issues with out-of-date PyC files, so don't write it. Finally, set up any other things like your Django settings module that you would like to use. And finally, how you should, the command that will run your application. So we say, please expose port 80. We'll serve the application over port 80. The entry point one, Docker magic. I can explain it in detail, but Docker's weird. And then the run script, which I'll cover in a second. And that will actually start our WSGI server. Docker compose. This is, again, how you run your application in development and compose your Docker image, your Python image, and your databases, and your mail servers, and your Redis, and your memcached, and all of these things together. Whatever you need, pick and choose. We tell it to build the current directory as the Docker container of choice. We tell it to run the Docker container in, so you can override what command is run. So back in the previous slide where we had the command, we're overriding that setting for development and saying, please just run the Django development server, which will give us library loading and nicer stack traces and debug messages. We are saying, please forward our host machine port 80 to the port 8000 in the Docker machine. So then we can access localhost port 80 to view the Django application. We are saying, please mount our current directory into the Docker container. So all of the code changes that you make locally for development will be instantly mirrored into the container, and you get your library, your loading, and updated Python code as you would in a developing on your host kind of environment. Saying, please use the dev settings instead of the deploy settings. We're saying, please link me to the database image. So that'll make sure that's started up first before it starts the Django one up. And then we're saying, please make me a database image. And it really is that simple. Like, just please run me a Postgres, and it will. And then you don't have to install Postgres on your host. This will run Postgres. It'll take care of managing the database, starting it, giving it, making a user. 2 lines. This is one of the great things about Docker. And then you've got memcached. Same thing, 2 lines. You've got memcached. And then you've got a debug mail server This one's useful. This is one I was mentioning earlier, that it just runs as a Docker image. It is an SMTP server, so you connect to it and say, please send me this email, and it won't actually send it, it'll just keep it in a mailbox that you can then access on port 9000 and view them in your browser. So it makes debugging emails really easy. You're not accidentally going to spam your clients. If you've copied down some production data, you're not accidentally going to overwhelm your network. If you get into a bit of a loop, it's just going to go to locally. You can view it. You can see how your email is going to look in a browser. It's great. The run script. This one is not particularly interesting. This is not the best way of doing it. I'm still learning how to do some of this, but you need to run your database migrations and any other startup migration commands, like collecting all your static files and uploading them to S3, something like that. Run them here. The other option is if you're running Kubernetes or something, you can have like a one-off pod that launches and runs these scripts, but if you're not quite that fancy yet, like me, you can just do it all in one go. Then you start your WSGI process, which a bunch of settings. Again, these settings, they're all in the code example, not particularly interesting right now, but just start WSGI that you can then access. That will get you a working Docker container, hopefully. You don't know until you tested it. So you can use this image that you've just built to run your tests in. And then you're testing the actual thing that you're going to run in production. Like you build this image, and then you invoke your tests in this image, and then you run that image in production. So you're testing the literal thing you're about to deploy. So the way you do that, you build your image, you start up a container, you put your tests directory in there, and then you run them. This is just a few command line Docker calls. I potentially controversially say that you should install your test dependencies in your production image. It's only a couple of kilobytes, megabyte, whatever, to install PyTest or any of those other libraries. But then you know that the image that you're about to test, unaltered, is the image that's going to run in production. You don't have to install anything extra, which will then modify the image. It's the thing that's running. And the extra file size is more or less irrelevant in this day and age. So yeah, test with as little modification as you can to your production image, because then you know what you're testing is what you're running. And you can use Docker to spin up any other dependencies like your database, just as you would Docker Compose. It will make setting up a test environment easy. So building an image, you run something much like that. This is a bunch of flags that I'll explain. So create a container, name it so we can find it, mount the tests for your code into your Docker container so that they're in there. We didn't include them in the production image because some test suites have like megabytes of sample data. So you don't want to include them in your production image because that'll get a bit excessive. Copy in any other configuration files like your linting files so that the linters can find them later. Set up any environment variables such as the ability to connect to databases. And then the last line with a tail -f is a sneaky little thing. It'll just do nothing. So you started the container, it's got all the code there, but it does nothing. So it's not actually running a Python process yet. Then we start it. We execute in that container our tests. Hopefully they all pass, fingers crossed. And then you can do other things. So the first one is running all your things unmodified, and then you can install any linting tools that you might want, like Flake8 and iSort. Copy in any extra directories, lint them, check them, run all your tests, and everything passes. It's magical. Some useful tools for this. So pip compile from pip tools. It allows you to specify requirements that are kind of broad and then locks them down. So that ties into the Docker's repeatable builds kind of thing. So if someone releases a new version on pip, you don't accidentally pull down the latest version and then break all your things because it's locked down. Please look into that one, it's great. It's kind of, I know the Node community and many other development communities have similar tools. pipenv does similar things. I like pipcompile for no particular reason. DJ database URL, if you're running if you're running Django, just allows you to configure your database with a single string instead of the 4 or 5 or 6 that you need to connect to your host. So it makes configuring with environment variables very easily. There is a demo. As I said, this is all up on GitHub. The thing I just described, I have built in GitHub and I have uploaded it. You can run it. It's just a Docker up or Docker Compose up, and it works. And then you can play around with it and have fun. It runs an application that looks a bit like this. It's a very simple to-do app that you can't even delete to-dos, but turn off the app. And that runs in Docker from that GitHub repo. So please play with that if you would like. I am slightly running out of time, but that gets you a very, very basic Docker image. There are real-world applications that require a bit more fanciness. So I have built 2 extra examples in the demo repo that please go and look at them. First one is that builds front-end assets. So most web development where you're making a front end as well, you'll need to run, or you might want to run, a node or npm build chain that will compile your CSS files and your JavaScript files together. You don't necessarily want to have Node in your final image because it'll bloat things up and then you'll have Node and Python in there at the same time. So there is an example that will compile your front-end assets, copy them into the Python image, won't have Node in there, and you can use whatever build chain that you would like. Works in development, supports library load, all those fancy things. A proper Node build chain is a topic for a completely different audience, so I'll let you discover those ones on your own. The other thing you might want to run is celery tasks, so any sort of build queue. So this is the generic thought here is you have your web server running, but you might also want to run other things like a task queue or any other thing that has all of your code available but runs a completely different command. So the celery task queue consumer is one of those things. And it will reuse the same build image to keep all your code in one spot, minimal duplication of configuration. And then you can use your Docker Compose to run the actual broker, which again is just 2 lines. And then magically you've got a whole celery task queue. So I have this repo. There's some examples. Fairly minimal changes to make the celery task queue run. I won't bore you with the actual details. Please look at them. And it runs celery. And there's also the front-end build chain in there as well. Cool. I'm just about done, and I wanted to take questions, so done.
Thank you, Tim.
Thank you. Thanks.
Are there any questions for Tim? Yes.
I think.
Hey, I just wanted to ask, why are you using a separate config file for dev and production? Why aren't you just having one config file and having everything come out through environment variables, since you're being set in Docker Compose, and then imagine they're being set when you deploy to production?
Yep. I've just often found that, so for staging and production, I agree you should reuse the one config file, but development, you just want some weird little different things. Like you might want to enable some extra apps, some extra plugins that you don't want to enable in production. If you start doing flags like, if is production, enable these apps, if in development, enable these other ones, then I've found the config file gets convoluted. Whereas if you just have 2 separate ones, like development is a starkly different environment to production. Like, you want to enable your live reload, you want to enable all these other things. So I just found it easier to just keep them separate. You could absolutely, if you wanted to, and this would preserve your environment in development and production and make them even closer. Of course, reuse the production config in development. Up to you.
Hi, how do you manage like logging in an application? Like if I wanted all the output of something to go to like Logstash or something like that?
You can configure logging as you would any other Python application. So if you're just using the standard Python logging library, then you can just configure it in the normal way. And then if you want to pipe it somewhere else, you could. I'm not that familiar with Logstash, but if that's an image you can run locally, then you could probably just run that in development. And if you're not running it in, and if that's not a thing you can do, if it's one of those cloud-hosted ones, then you could put the configuration for that in your production config as opposed to your development config, which might have a completely different like console logging. There's another reason to have a difference. But at the end of the day, it's just running Python, so you configure it in the same kind of ways.
Hi, thank you for the talk. You mentioned that you wouldn't really use Docker Compose in production. Why is that?
To make a significant change to your environment, such as environment variables or different image and that kind of stuff, I haven't found a way in Docker Compose to gracefully restart just that one section. You have to bring the whole thing down and back up again. Also in production, you might want to have like a shared database for a couple of your apps as opposed to one database per app. Or memcached or Redis or as appropriate. So you would have to have a duplicate config for production and development. And in production, I would advise using something like Kubernetes that does all the magic for you. A lot, like, I don't think Docker Compose that's not its intended purpose, I don't think. So it can't do nice rolling updates to images and that kind of blue-green deployment and all those fancy things.
Hi. Where does a process monitoring tool like Supervisor D fit in?
Not always inside your Docker containers. So Supervisor D or those process monitors could theoretically run your Docker images. So if you had if you had your web application Docker image and a couple of Celery worker Docker images, then Supervisor D could theoretically run those processes on the host system. And with a bit of magic, you could even run that inside a Docker image that then runs Docker images on the host image, a host computer. That's getting a bit fancy. But you are recommended not to run multiple processes or multiple apps inside a single Docker container. So you rarely run Supervisor D within your Docker container itself.
And that's all we have time for. Please thank Tim again.